So, welcome everyone to the Tom class. We'll continue the session. Others will join later or may go through the recording. So, uh, as you know, like we have studied the theoretical part from all the topics, and from last two classes, we have started the problem solving sessions. We solve the problems on gears, gear trains, mechanisms, and machines, velocity and acceleration. Okay. In the today's session, we will focus on the smaller topics which are like comparatively what we have studied before, like cams, follower, dynamic analysis of the linkages and governor, etc. Okay, so uh, so in this topics, we'll probably directly go into the problem solving sessions. Okay, because there is not much theoretical background. Um, we have studied different. So, for example, in cams, if we say like we have studied different types of cams and followers, and then we have studied how to calculate displacement, velocity, and acceleration, um, effort, etc. Okay, so this is what we have studied, and how we can um, so suppose displacement is given, then how we can judge the velocity, accelerations, and all. That is what mainly we have studied in this topic. Okay, I remember explaining you through the figures, like for example, the displacement plot is given, then how velocity will vary, or how the other parameters like acceleration, etc., will vary. Okay, so those kind of questions we'll expect here basically in this topic. And apart from that, you can expect some like questions which can be solved by like general uh, mathematics as well. Okay, so or normal formulas which we know. So um, and we have studied the exam term jerk also in this case. Okay, we have studied velocity, acceleration, and jerk. Okay, velocity, we know it's a first derivative of like theta with respect to time. Okay, angular displacement with respect to time is velocity, angular velocity. Angular acceleration is double derivative with respect to time, and triple derivative with respect to the so this is a new concept we have studied in this topic, d3s by dt square. Okay, so we know, like, if you take a derivative of velocity, you will get acceleration. If you take a derivative of acceleration, you will get jerk, and so on. And on that basis, like we can decide how the cam and follower motion is there, whether it's jerky or it's smooth. Okay, um, so and so the things we have studied, like mainly on yeah, it's a d3s by dt cube. Okay, yeah, and the rest of the things, like, were bit theoretical, like different types of cams and followers and so on. So let's try to go through some previous year questions, and try to understand how we can solve them. Okay, so write down the first first question, or you can just go through it and try to solve it. No need to write, maybe, because you will have all these recordings with you, and I'll be uploading all these PPTs as well. Okay, um, so in a cam follower mechanism, the follower uh, needs to rise through 20 millimeter during 60 degree of cam rotation. Okay, the first 30 degree with a constant acceleration, uh, then with a deceleration of the same magnitude. The initial and final speeds of the follower are 0. Okay, The cam rotates at a uniform speed of 300 rpm. So omega is given to you. That of cam is given. Okay, 300 rpm. The maximum speed of the follower they are asking here. Okay, so try to understand here. The follower is like in this case, as we can see, is it's as they have mentioned rise. Okay, you can expect it as like a linear motion. The follower is doing a linear motion. Or reciprocating motion, whereas we have a rotary cam because they have mentioned the cam is rotating with some degree. So it's like a, try to imagine the um, cam follower mechanism here. It looks like a rotating cam and sliding or you can say translatory motion of a follower. Okay, so think on it. How can I will just wait for 1 or 2 minutes, try to solve it first on your own, and then I'll help you with it. So what they have given is n given, oh sorry, omega they have given indirectly. Okay, so let's say if we have a cam and cam is rotating with some omega, we know, but omega they have not given, they have given you the n. So indirectly they have given you omega. So this is first hint to you. Try to use this hint in order to solve this question. 2 pi n by 60 will get omega. 2 pi into 300 divided by 60. So you will end up with a 10 pi. So you know the angular velocity. Now, and they have also given the initial and final speeds of the follower are 0. So keep in mind that you, let's follower is doing a translatory motion, for example. So the initial and final speeds of follower are 0. So u is equal to, for example, 0, u initial, and u final, or let's say velocity initial and velocity final is 0. This is also given to you, and they're asking you the maximum speed of the follower. Okay, so when can you expect the maximum speed of the follower? Think on it. Let's read the background for it first. In a cam follower mechanism, follower needs to rise through a 20 millimeter during 60 degree of cam rotation. Okay, the first 30 degree with a constant acceleration, and then with a acceleration of the same magnitude. Okay, so first 30 degree it is you can say uh, performing, so it's actually increasing its velocity. So we have some acceleration there, constant acceleration, which we don't know, but as of now what they have given is like 30 degree, first 30 degree we have a constant acceleration. Okay, so how much time it can take? Calculate it. How much time required or time taken to move crank by 30 degree? How much will be the velocity is equal to distance divided by time? Sorry, omega is equal to distance divided by time. So time will be angular displacement divided by omega. So angular displacement is 30 degree, we know. In radian it will be pi by 180 into 30 divided by omega, which is 10 pi, we have just calculated, and it will come around 1 by 60 second. Okay, so 1 by 60 second, or these many seconds, 1 divided by 60 seconds are required um, to move this cam by 30 degree. Okay. Mm, so so during this time, we know like our follower is you can say moved by a distance of 20 millimeter from the initial with the initial velocity of 0, because they have clearly mentioned the it needs to rise the follower by uh, 20 millimeter. So use that concept here and apply. Uh, but they have mentioned the first 30 degree with a constant acceleration and then with a deceleration. Yeah. So and that is also of the same magnitude. So you can say that, let's say what you know is S is equal to ut plus half at square. V is equal to u plus at. S is equal to ut plus half of at square, and V square is equal to u square plus 2as. These three formulas are applicable under constant acceleration processes that we know. So we can make use of this formula. S is 20 millimeter here, but we know like first half is only 30 degrees. So half of that distance I'll take, that is 10 millimeter, right? So which is 0.01 will be equal to half of ut. Initial velocity is 0, so I'm using this formula. Okay, here S is equal to ut plus half of at square. U is 0 because initial velocity of the follower is given as 0. um, ut plus, and the time is like 1 by 60, correct? Ut plus half of a into 1 by 60 whole square. So this will give us the value of a. Okay, just calculate it. This should give us the value of a. So we know that in this time 1 by 60 second, um, the follower is reaching the 10 mm distance, and during that time the acceleration will be, so I think you should get it as 72, right? Good. 72 meter per second square. So this is your acceleration. Okay. Um, and then what they have said that then with a deceleration of the same magnitude, so deceleration will also have the same magnitude. Uh, the maximum velocity of the follower we want. So v is equal to u plus at. So maximum velocity you can get it from this formula itself. Uh, this is your acceleration. Okay, as you know, as what is the acceleration with respect to time? If your velocity is increasing, it means you have some constant acceleration, right? So this is slope is constant, it means you have constant acceleration. This is with respect to time, and this is your velocity. Okay, so now from this formula you can directly get the value of the Vmax. So I'll take it here. Vmax, u is 0, you already know that is initial velocity is 0 plus acceleration into 1 by 60 uh, is your time. So ultimately you'll get 1.2 meter per second. Yeah, hence option B is correct. Okay, so so this kind of questions you can expect for 2 marks, where like here we have to use couple of formulas like S is equal to ut plus half at square and V is equal to u plus at. So but you can imagine like everything is can be solved with this basics of constant velocity and acceleration problems. Okay, this kind of problems you might have studied in mechanics also. uh, More or less they are same, but here the arrangement is given, which is cam and follower. So your main task is you should be able to understand what kind of cam follower mechanism is given, whether it's a turning or a rotating cam and rotating follower, or rotating cam and sliding. So these kind of things you should imagine while reading the question. Things will become very easy. Okay, so let's go to the next question. Yeah, in a cam design, the rise motion is given by a simple harmonic motion, SHM, and they have given you the value of S also, that is equal to h by 2 bracket 1 minus cos of pi theta divided by b. Okay, um, where h is total rise. Okay, theta is camshaft angle, beta is the total angle of the rise into, can say, the jerk is given by. So you are supposed to calculate jerk here. So I have already explained you what is jerk. Jerk is the derivative of displacement with respect to time. So if you calculate d cube s with respect to dt cube, you will get. Okay, jerk is given by third derivative of displacement with respect to time. S is equal to h by 2, 1 minus cos of pi theta by beta. So if you take a third derivative, h by 2 will remain as it is. First derivative we are taking. Okay, first derivative of 1 is 0, so that term anyway will go. If differentiation of cos is minus sign, correct? Minus minus will become plus. So sine of pi theta by beta, and into pi by beta will come. So this is your first derivative. If you take second derivative, what will happen? It will become pi square by beta square. If you take third derivative, it will become pi cube by beta cube. Okay. So pi cube by beta cube h by 2. First derivative is sine, second derivative is cos, third derivative is again minus sine. So basically, it will be like minus sine pi theta by beta. So which option is correct here? Option D, correct. Yes, option D is correct in this. Okay. So just by looking into the option, you can take it. Okay. Can I proceed to the next slide? Yeah, take this question. Think on this question, okay? The mechanism is given below. If the angular velocity of the eccentric circular disk, this is the eccentric circular disk, it's not rotating about this point, it is rotating about this point. Okay, so it's a eccentric circular disk which is acting as a cam in this case, and omega is given as 1 radian per second. Okay, this is 1 radian per second. They're asking the angular velocity of the follower. So what is the angular velocity of the follower? This omega. Okay, they are asking here at this particular instant. Are you following it? Yeah. So it's like your normal mechanism itself, but in the terms of cams on follower. Assume this cam as a turning link, or just turning link, and your follower is also turning link. So two turning links are there. One is like this, and so another one is like this at this particular instant, right? So this is also turning, so automatically the follower will also turn here, but we don't know this distance here. Okay, this particular distance, we also don't know this particular distance, but other distances are given. Make use of it and try to come up with the solution. Okay, I'll give you 2 minutes on this to think and solve. And if you face difficulty, then I'll help you with it. Okay, I'll draw a simple diagram for it. Okay, just to make you clear. So whenever we draw, so this is like a tangent to the circle, right? And whenever you draw, whenever you join it to the center point, you will get a 90-degree angle, right? So this is 25, this total is 50, and let's assume that you are assuming it as alpha, this angle. Then can I write it as a 50 cos of alpha? Is it correct? Are you following it? Yeah. Okay. So now uh, uh, we don't this distance. We don't know whether it's a straight line or whether it's an inclined line. So I'll just, but this is the shortest distance. I'll call it as x. Okay. And other angles we don't even. Okay. And this let's call it as a beta, and let's call this angle as theta. Okay. I'll name it as maybe p q and s. So if I just consider a triangle p r and s, it's a right angle triangle. Okay, triangle. And in this case I can say, let's say cos of theta is equal to base divided by hypotenuse. mm, Hypotenuse is 50 here. So theta is like 1 by theta is, sorry, cos inverse of 1 by 2, which is 60-degree. Okay, so theta is 60-degree, and alpha you can directly say it as 30-degree now. Okay, because sum of all the angles in a triangle is 180. So one, as this is 90, this is p, this is r, and this is s. We said that this is 60. This has to be 30-degree. Okay, so I have given you enough hint now to solve the question. Okay, um, with this hint, you should be able to get the value of x, and you should be able to calculate the um, angular velocity of the follower. So think on this and tell me your answer. Okay, here I have already kept that diagram drawn to so um, this is this you can use this is 1 rem per second. Okay, and I have also mentioned here the velocity um, vector. Okay, so this is your velocity vector, correct? For turning link, always velocity is perpendicular to it. So it's like from center, it's like a link like this. Okay, and the velocity at the point P will be perpendicular. So that's why this velocity is in horizontal direction, and it will have two components in this vertical direction, and one other one is in the horizontal direction. Okay, so I hope you understood like how this velocity uh, vector is drawn, and how the you can say steps in the vertical and horizontal direction are or how its components are drawn here. Okay, okay, so um, with this hint, what can you expect now? Like, what is the velocity at point P? Velocity at point P is equal to omega of the crank into PQ, right? PQ is a distance. We are writing it as x. So, what is your omega? Omega is already 1, we know. And what about PQ? If you use a sine rule, basically, can I write phi divided by sine of beta equal to x divided by sine of 60? Can I write it like this for sine rule? And from this, x is equal to 5 sine of 60 divided by sine of beta. And so omega is 1 and PQ is our x. Okay, so can I write velocity at point P will be 5 sine 60 divided by sine of beta, right? I can write it like this. And from this, um, we can calculate omega for this link, because velocity of this follower at point P will be v sine of beta, right? So I'll write here of follower will be perpendicular to that follower, and that is given as at P will be equal to v sine of beta, uh, or vp sine of beta rather. Mm. And vp sine of beta will be 5 sine 60 divided by sine beta will get cancelled, so it's directly 5 sine of 60. That's all. And now you want omega. Omega is equal to v by r. Velocity is 5 sine of 60, and r is 50 cos of alpha. Alpha is 30 degree, we have already said, right? So sine 60 is equal to the cos 30. So this will get cancelled out, which is root 3 by 2, and 5 by 50 is 0.1. Okay, so hence option B is correct in this case. Sean, no, 0.25 is incorrect. Maybe you have missed this particular step, velocity of the follower. Just check it once. Yeah. Is it clear to you? Can I move towards next question? Yeah. So here it's like pure mathematics you are using to calculate the different angles and lengths, but ultimately just v is equal to r omega formula you are using. So nothing much. In camps, you can expect like these kind of questions where simple formulas are used, but you need to implement mathematics, like taking the derivatives in order to calculate the jerk, calculating the distances and angles by using general mathematics. Okay. Um, let's take one more question. Consider a rotating disk cam and um, translating follower. Okay. Uh, try to understand this question. Consider a rotating disk cam and a translating follower with a zero offset. So we have a cam like this, and we have a follower. Okay, maybe like this. Follower is and the cam is rotating like this. Okay. Okay, fine. So now, which of the following pitch curves parameterized by t lying in the interval 0 to pi, so within 0 to 2 pi, sorry, means in a complete rotation of this cam, is associated with the maximum translation of the follower? So they have given different motions A, B, C, and D. Out of these motions, okay, so it can be simple harmonic, it can be anything, okay. So they have given different values of x and y, and you're supposed to check out of this motion in which case you will get maximum translation of the follower during full rotation. So this follower will translate maximum in which of these four cases? I hope you understood. Um, so just I'll give you a hint. Maximum translation of the follower is given by under root of x square plus y square. X is the function of the time and y is also the function of the time. X and y values are already given to you in this all four. Make use of it and calculate the d value here. D means displacement, right? So under root of x square plus y square. Um, so you will get um, how far your follower will reach in these motions, and whichever is the giving you the maximum value, um, that will be the you can say correct answer in this case. Okay, so I'll wait for 2 minutes to um, give you some time, solve it, and let me know your answer. Okay, maybe I'll try to help you with the first one. So in the first case, what is a x is equal to cos of t, and what is y is equal to sine of t. So x under root of x square plus y square will be cos square t plus sine square t. We know that cos square theta plus sine square theta is equal to 1. So under root of 1 is 1. So in this case, your displacement is 1. Similarly, try to calculate displacement in other cases. Um, in second case, it will be x is equal to cos t again, so cos square t, but y of t is 2 sine square t, so it is 2 sine t is 2 sine t whole square is 4 sine square t. Out of this 4 sine square t, you can write 3 sine square t plus sine square t, and this sine square theta plus cos square theta will become 1. So it will be under root of 1 plus 3 sine square t. Okay, and in between, let's say 0 to 2 pi, uh, the maximum value of sine can be, let's say, 1, we know. So 3 into 1 is 1 plus 1 is 4. So it will be maximum of this function will be under root of 4, which is 2. Do you agree? Because the maximum value of this function will depend on the maximum value of sine of t, right? And sine t maximum value is 1. So considering that, we can say that if the follower is following this motion, then in that case, uh, the maximum displacement would be 2. So similarly, try to solve it in third and fourth case. Yeah, let me just help you with it. So we already did this case 1 and case 2. Dmax is 1 and Dmax is 2, we said. Now case 3, half of cos t, half plus cos t is your x and y is 2 sin t. I have already written as in order to make like calculation easier, okay, or to save the time. So the this is square plus this is square, okay. So you will get here cos square theta plus sin square theta for sure, okay, because we have cos theta here, we have sin theta here, okay, and that you can simplify as cos square theta plus sin square theta equal to 1. But before that, a plus b whole square formula you should use here. What is a plus b whole square? A square plus b square plus 2ab, okay. So using that, 1 by 4 plus 2 times 1 by 2 into cos of t is cos of t plus cos square t, and 2 sin t whole square is 4 sin square t. So from this you can split it into sin square t plus 3 sin square t, okay, and this sin square t and this cos square t will become 1, and that you will add with 1 by 4, you will get a 5 by 4 plus cos t plus sin square t. I hope you understood till this, okay. And its maximum value will depend whenever you will get maximum, because you are multiplying 3 to sin t, sin square t basically. So whenever this function will be maximum, whenever your sine function will be maximum. So when sine function will be maximum, you know it's when theta is equal to pi by 2. But at that instant, cos will be 0. So you'll make this 0, you'll make it 1. 3 times 1 is 3. So 5 by 4 plus 3 will be more than 4. Okay. 5 by 4 plus 3 is like I think 12 plus 5, 17 by 4. Okay. So it's basically this number is more than 4. And if you take a root of it, you'll get a number more than. Okay. So basically the third case is giving you the largest value compared to case 1 and case 2. Okay. So case 3 is giving you the largest value. So similarly, if you calculate it for the case number 4, you will get 1 by 5, 1.5, which is again lower. So that's why you should say here option C is correct. Okay. Here is 2.06 and here you are getting 1.5. Are you following it? If you have a question, feel free to ask. Okay. Ultimately, what we are doing is we are calculating the maximum of the follower in all this, and your option is giving you the largest value. That is what you are supposed to select in this question, because the question is the maximum translation of the follower during the full rotation about the center is. Okay, so your question is how did we take d is equal to under root of x square y square? Okay, see, question is like um, uh, from the initial, so basically the cam and follower is there, right? As cam is rotating, follower is also moving, and the motion of the follower is like given in terms of, let's say, um, so this is simple diagram, but it doesn't say like it may not be the accurate one. Okay, so the displacement is given by, so for example, the x is varying with respect to time is like this and y is varying with respect to time is like this. Okay, so this is your cam motion, for example, which is given. So if you remember, like maybe in the previous question we have some displacement, so for example like this, so as here they have directly given value of x, Okay, here they have directly given you the value of x, but in this question they have not given you the value of s. Okay, here what they have given, how x is varying and how y is varying. You know, let's say if you have a point x and y, then the distance from 0 comma 0 to x comma y, how you will calculate? You calculate it by using um, x minus 0 whole square plus y minus 0 whole square, right? Under root of it, because this is your y, this is your x distance and this is your y distance, and that's how you calculate it, right? So that's why under root of x square plus y square is d here, because uh, you are calculating it from the center of the cam, which is 0 comma 0. They already given you here the rotation of the cam rotating about the center, x comma y is equal to 0 comma 0. So you have to find the maximum translation of the follower from this center point. Okay, so here is a description for it, which you can use in order to calculate the d. Okay. um, Fine, can I move towards next slide? Okay. uh, mm, it looks like you are typing something. Okay, Sean, well, let me just come back to your question. X and y gives you the pitch curve about the origin, and the maximum distance from the origin is equal to, yeah, correct. So basically, um, you can take any point, you can take a point, for example this point. Okay, um, that particular point, yeah, basically, or you know the pitch circle, right? In case of cam and in case of cam and follower mechanism, depending on whether it's a knife edge or a roller follower, we have different pitch curve. So that pitch curve, you take any point on that pitch curve. So in this case, I think the pitch curve, because we have chosen the pointed follower, so uh, knife edge follower. So if you take a point on it, then that point on the cam will follow this pattern, like x is equal to cos t and y is equal to sin t with respect to t. So from this, like you can at each time you can calculate the distance. So for example, this position will be at certain time t, the at certain other time t the position will be like this. Okay, so this point is moving on the pitch curve, and you know that, like when this, for example this point comes here, at that instant you will get the maximum displacement. Okay, so maximum displacement is again given by, as I said, the distance between the origin of the cam, which I have shown here, and the point x comma y, which is on the here, like something maybe this point. Okay, which is like a farthest point from the um, center. Okay, so this is, for example, your um, d. Basically, indirectly you are calculating this. Is it clear? Yeah, coming towards the uh, another topic, dynamic analysis. So um, here here again we have studied, like if you get a 4-bar chain, or if you get a slider crank mechanism, then how can we let's say, calculate the velocities and velocity accelerations as well as the forces in the system, right? So that is what we have studied in this topic. um, and uh, yeah, I don't expect like directly we should go through it, because um, the concepts were very less in this, as I remember. But one of the concept which we have studied is like a, for example, mechanical advantage, you should know. Okay, what is mechanical advantage? It is output torque divided by input torque. Okay, and this will give you the mechanical advantage. So for example, if you have a 4-bar chain, you should know the toggle position for it. So toggle position is like, um, whenever two links are linear, okay, in that case, the that kind of position you can expect it as a toggle position, okay, in a 4-bar chain. Other things I don't, um, you already know it. We can just go into the problems and it will be clear. So but you already know, like, this is, let's say for example, it's a slider crank mechanism. If you know this is theta, if it is phi, this will be 180 minus theta minus phi. This is R and L. This is a general, like, um, slider crank mechanism, and with this you should be able to calculate all lengths and angles. So this length will be R cos theta. This length will be R, L cos of phi, and the vertical height here at this particular instant, that will be R sine of theta, and that will be equal to L sine of phi. Okay, uh, and then you can apply again velocity triangle in this to calculate the, so you can actually draw the velocity triangle, and same angles you can apply there. Okay, so I'll not go into that details, but that we have studied, if you remember. Okay, so I, in this topic, main is like you should know, or you should make use of, or apply the velocity triangle, use that knowledge in order to solve the problems mainly. Okay, so that is what expected here. So let's start with some simple questions first. um, so you have a velocity, the cross head velocity in the slider crank mechanism for the position shown in the figure is what they are asking you. Okay, um, so just write down this question first, think on it, what they have given, and what is expected here. Just a minute, I'll share my screen again. I think I have to share my screen. new screen now. Yeah, yeah, think yes. Set, yeah. Just this. Here you have the definition of cross-head velocity. I'm giving you the solution part of this question. Cross-head velocity is this. Okay. Omega times I center 2 4. Okay. I'm back to your question now. So this is your uh, cross-head velocity. So write down this velocity of head is omega times I center 2 4. Okay. So let me just show you. Okay. Voice is breaking. Just give me a minute. I'll try to fix it. Hello. And see my screen. How about now? Is it? Am I audible properly? Yeah. Okay. So yeah. Um, so as I shown you before, velocity of cross-head here is omega times distance from O to I center 2 4. Okay. Um, O is here. I 2 4 is here. So you can just as if now consider this a triangle O E and I center 2 4. Okay. And you can calculate this distance O to I center 2 4 by using this. So So this angle is what? This angle is 90 minus alpha, right? 90 minus alpha. Um, if you join it, um, other angles also you can uh, can you write like this? OI center 24, okay, OI center 24, let's say cos of beta, mhm, is equal to OC cos of 90 minus alpha plus beta, something like this. Think on it. Yep. So from this, what they are asking is this can be written as uh, velocity is equal to, you know, VC is equal to OC into omega basically. So omega they are asking you, um, and no, they are asking you the velocity of the crosshead, which is so for that you have to first calculate the omega, and again put into this. So I can write here VC, for example, velocity of this particular point from O is OC into omega. Okay, if you assume this as one link which is rotating at omega, the velocity at particular point C is equal to distance between O to C into omega. And if you compare these two together, I can write so this cos beta, if I take it on this side and multiply here as sec beta. Okay, and so indirectly I'm saying this as our omega. Okay, um, yeah, so yeah, so that's all then. OI2, I think screen share got ended. Maybe I'll share again. Just give me a minute. Mm. I'll try to change my network connection to make things little smooth. Just give me a minute.
You are currently the only person in this conference.
Hello. How about now? Can you hear me and see my screen? Yeah. So basically, I24 into omega would be VC cos of 90 minus alpha plus beta into sec of beta. Okay, and considering this, option B is correct. Yeah. Okay. I'll go to the next question. Yeah, try to go through this and solve it. Consider a triangle formed by connecting the rod crank of ice engine as the two sides of the triangle. Okay. Okay. For example, like they are saying it like this. Um, Maybe something like this. Crank and connecting rod. Okay. Suppose this is a crank and this connecting rod, and if the maximum area of the triangle occurs when crank is at 75 degree, okay, this will give you the maximum area. Okay, the ratio of connecting rod length to the crank radius is okay. So this is R and this is L. So what they are asking you is the ratio of L by R in this case. Okay, so this is what they are asking. Try to solve. I'll give you 2 minutes of time to think on it and solve. What they are saying is at 75-degree angle, you will be getting maximum area of the triangle. Let's call this point A, O, A and B. Okay, so this is, let's say, which is at a 90-degree. Um, okay, this is at a 90-degree. With this hint, try to calculate the area. Half of um, um, maybe okay. Hmm, yeah, just think on it. Like maybe alone, it's not even needed to calculate the area. Maybe yeah. Think on it and try to solve. Okay, just give me a minute. I'm connecting through my phone as well, parallelly. Currently, I'm not able to see your comments, so just give me a minute. In the meantime, you to solve this question. Yeah, spend some time on this and try to solve this question. Hmm. Do you have any answer here? No. Okay. Let me just give you a hint here. So let's rub this stuff and I'll read our figure. So they have given only one angle, uh, but as you can clearly see, this is how the triangle looks like. This is like we don't know this angle here at A, what it is, whether it's 0, whether it's 90, maybe 90, may not be 90. Oh, okay, all these points. This is our crank, and this is our connecting rod. Can I write area of this triangle is equal to 1/2 AB into um, OA sine of this angle A, OA sine of angle A. Okay, and if you um, let's say, yeah, if you, for example, differentiate it for that particular angle to get the maximum area, you will get that angle A is 90 degree. So basically, just by looking into this example, this formula, you can say that um, whenever this term sine of A is maximum, our area is maximum, and that this term maximum value of this will be 1, and that will be only when the angle A is 90 degree. So you can conclude that this angle has to be 90 degree uh, in order to get the maximum area. Okay. So from this, now consider a triangle now, OAB. Consider a triangle, this complete triangle OAB, and it's right angle triangle as we have defined, and tan of, let's say, 75 degree, because this is 75 degree they have given, this 90 degree, is perpendicular divided by base. Perpendicular is L, that is connecting rod, by base OA, which is L by R, we can say, and it is 3.73. Okay, tan of 75 is 3.73. That's why option C is correct in this case. Yeah, okay. I'll go to the next question now. Yeah, this is also a little tricky question. For a mechanism shown below, the mechanical advantage for given configuration is. You already know mechanical advantage. Formula is given by output torque to the input torque. Okay, or it can be also written as omega output to, because torque is equal to R times omega, right? Okay, so think on this now and try to solve this question. Sorry, not this. Uh, it's omega input by output, inverse proportion. Yeah, I was wrong. Check the formula again. It's omega input by output. Yeah. Yes, T out equal to T. Yes, total moment. You can say at the, which is given, versus the output, is should be same. Yeah. Or power, we can say, power input equal to the power output formula we have used. So torque into omega will be power. So input torque into input omega will be equal to output torque into output omega, and that's why the ratio of torque and ratio of omega will be different, will be opposite. Yes. So with that, tell me the answer for this question. So it's like half of all already solved. You can clearly see here there is a slider. Link is slider. Output link is slider. Okay. Hence omega for the output will be 0 itself. Do you agree? So if output is omega for output is 0, whatever will be the value for the input, anything upon 0 will be infinity. So In this case, we cannot, let's say, calculate mechanical advantage. The terminology mainly we use only for the 4-bar chain. Are you following? Because here output link is slider, and slider is having a reciprocating motion, not a rotary motion. So the answer is infinity. I'll go to the next slide for a new question. For a 4-bar linkage in a toggle position, the value of mechanical advantage. Again, a question on mechanical advantage. Okay, so same formula I will rewrite here. That is mechanical advantage is equal to omega input divided by omega output. Okay, so let's consider this 4-bar chain maybe. Okay, so 1, 2, so first link, second link, third link, and fourth link. Okay, for example, it's turning like this. So basically, at the toggle position, the you can say the omega 4 will be 0. Okay, because let's call them it as A, B, C, D. Okay, so the CD link is your fourth link, which is output link, and omega 4 corresponding omega will become 0 at the toggle position. Like whenever link 2 and 3 will come in a single line, try to imagine it, and at that position, like you can expect the output link will have the 0 omega. So make clear that whenever you have a toggle position, the output link or 4-bar chain will have 0 value of omega, and hence again in this question as well, your answer is infinity because omega 4 is infinity. Okay, so just to recall, um, in case of slider crank mechanism, slider motion is translatory motion, so omega is 0 in that case. Okay, and that's why mechanical advantage will be infinite. Also in the toggle mechanism, omega 4 is 0. The angular velocity of the out angular velocity of the output link will be 0. Hence, the mechanical advantage will be again infinite in this case. Okay. I'll go to the next slide and just try to solve this question. A rigid link PQ. They have clearly mentioned it's a rigid link. Okay, it is 2 meter long and oriented at a 20-degree angle to the horizontal as shown in the figure. The magnitude of direction of velocity VQ and VP is already given. Okay, the magnitude is also given, direction is also given. The velocity of P is in this direction, velocity Q is in this direction. Okay, the magnitude of VP they are asking. Okay, direction of P is given but not the magnitude. Okay, so that is what they are asking. Magnitude of VP in meters per second. Solve this question. I'll give you 2 minutes of time. It's a rigid link. So hint here, if you want, I can give you that the if it is a rigid link, velocity along that link, you can say linear velocity along the link will be same. Try to uh, so this is your BP. What will be this if you calculate the velocity along that uh, link? Will it be BP cos 20, right? Yes. So similarly, this is point Q. There also try to calculate the velocity along that link. This is at some 45-degree angle maybe. Okay. Maybe like this. Let's say this is the angle. Like this. So this is 20, means this also has to be 20. And this total is 45. So this remaining is 25, right? And this is VQ. Will it be VQ cos 25? Yeah. So yeah, VP cos of 20 is equal to VQ cos of 20. Can I write it like this? Because velocity along the link will be same as it's a rigid link. Okay. So considering that VQ is already given to you, that is 1 times cos of 25 divided by, sorry, here it's a divide. I have made a typo here. Divided by cos of 20 will be your answer. So VQ is 1. 1 multiply cos 25 by 20 is 0.9644. So 0.96 is the correct answer. Option D is correct in this case. Okay, is it clear to you? Yes. Fine. Let's take another question. Okay, little tricky question. A slider crank mechanism has a slider mass. Okay, some mass term came now. 10 kg. Stroke of 0.2 meter. What is meaning of stroke? Can you tell me? What is meaning of the stroke? In case of IC engine, you know the stroke of the engine, right? So what is stroke? Displacement of the position. Yeah, but it's a distance between top dead center to the bottom dead center. Okay. So basically, let's say this is your, for example, R and L. Okay. So whenever this R will come here, the L will be here. So this is your top dead center, right? So your piston will not move on the right hand side of this top dead center. Do you agree? So this is the dead center, after which it will not move. Similarly, when let's say R is here, okay, so if it completes a rotation, then let's say maybe um, the piston will be somewhere here at that particular point. Okay, and so this is your bottom dead center, and distance between this is called as a stroke. So can you tell me what is the value of stroke generally? If R is the let's say crank um, length, and L is the connecting rod length. What is the stroke length? What is the length of the stroke? No, it's not. See, R plus L is what? It's a complete distance. So R plus L is this. This is R plus L because this is R and this is R and this is L. So this is R plus L. That is not stroke. Stroke is this TDC to BDC. Now think R plus L is this distance. And what about this distance? This is L minus R. L minus R. So R plus L minus L minus R. If you do, what will you get? R plus L minus L plus R. So that is 2R. So stroke is equal to 2 times the crank length. Are you following? So this is also a new concept you should know. Okay. Also, I would like to introduce one more point at this moment as we are like as this terminology came. Okay, I'll rub this. So generally, stroke is equal to 2 times R. But let's say if your piston can move both the sides of, well, let's say on right hand side as well as left hand side. For example, if the arrangement is made in a such a way that, let's say, piston is like this, but it can come here and it can go here. When it is possible, if your connecting rod and if your crank is of same size, this is also R and this is also R, for example, what will happen when this, let's say, it's rotating and crank comes here, then piston will come at this location only, right? And during next revolution, it is possible that piston will move in this direction rather than going into this right hand direction, right? So because of the inertia. So in this case, the extreme positions would be, this is your crank, this is your connecting rod, this is your piston, and on the left hand side also you will get, this is your connecting crank, this is your connecting rod, and this is your piston. So in this case, 4R is your stroke. Okay, so if crank and connecting rod are of the same size, then 4R will be your stroke. Okay, and if crank is smaller than connecting rod as usual, in that case, you will have a 2R as a stroke length. Okay, so keep this thing in your mind. Okay, coming towards this question now, because this kind of questions also they last, so that's why I'm telling you it can be a theoretical question, so you should know how to calculate the stroke length. Okay, coming to this question, a slider crank mechanism has a slider mass which is 10 kg. Okay, mass of the slider, and stroke is 0.2 meter, which is rotate. Okay, and it rotates with a uniform angular velocity, right per second. The primary inertia forces of the slider are partially balanced by the revolving masses of 6 kg at the crank. Okay, placed at a distance equal to the crank radius. Neglect the mass of connecting rod and crank. Okay, so this question is from balancing. Okay, balancing of the forces. Okay. Um, neglect the mass of connecting rod and crank when the angle with respect to slider axis is 30°. The unbalanced force normal to the slider is. Okay, so we have studied balancing in case of slider crank mechanism, if you remember. Okay, so we have calculated the piston force, and from that piston force we are calculating the force in the connecting rod, and then from the force in the connecting rod we have calculated the force on the crank. Okay, and basically crankshaft at crankshaft. So forces we have calculated, and we have seen what is the um, uh, unbalanced force and how can we balance it. Okay, and we also seen that there is no, like, we cannot completely balance it, yeah, because there will be always a vertical component if we balance the horizontal force. Okay, and it's like a trade-off, so we have to partially balance it, right? We have studied this part. So now try to imply this that part here. Maybe I'll draw a diagram to explain the point here. So this is the piston connecting rod, crank. This is rotating at omega. Let's say making an angle theta. Anything is given to you apart from this? No. 51.96 is not correct answer. mm, the unbalanced force is mr omega square sine of 30 degree. Mass is given to you. Only thing is r you have to calculate. So stroke is 2 meter from this. What is the value of r? R is stroke, because 2r is the stroke. So r should be equal to 0.1 meter. 0.1 meter means 100 millimeter. Okay. Um, and unbalanced force is mr omega square sine of 30. Mass is um, basically 10 in this case. R is 0.1 meter. Omega is 10 square into sine of 30 is 1 by 2. Should get 30. Okay. So 30 Newton is the answer in this case. Okay. So if you are hesitating here, let me know. But I hope it's clear. We have studied in dynamic analysis, like how can we calculate the unbalanced forces. Yeah. Can I proceed to the next slide? Okay. Just a minute. Okay. Consider another question. Here we have offset slider crank mechanism. Okay. And this question is for the quick return ratio. Mm, um, The offset slider mechanism is shown in this figure. At this particular instant, quick return ratio is what they are asking. Okay, the quick return ratio is considered to be greater than 1. Okay, so the value is um, obviously here greater than 1, and what is that they are asking? Think on this question. I have the simplified diagram for this already drawn on the next slide. Okay, but I want you to try on your own first for 1 or 2 more minutes, and if you still find it difficult, then I'll help you. Okay, I have already drawn the simplified diagram on the next slide, which will help you to understand how we can actually find um, quick return ratio. So um, you already know quick return ratio is time for um, cutting divided by time for return. Okay, and time for cutting is derived from the angle which is taken by the um, um, mechanism in the cutting stroke. Okay, so time for cutting divided by time for return. So basically, this angle here, you will have some angle. Let's say uh, cutting angle. That's maybe theta, for example, and beta. So this ratio will give you the um, quick return ratio, and this is greater than 1. This is what indirectly they're asking you. Okay, so think on it. You don't have anything given in terms of time, but you have given in terms of length. So it should be possible to calculate the angle. So think on it, like what will be the angle during cutting stroke, what will be the angle during return stroke. Okay, I'll give you a simplified diagram here. Think here. Okay, um, mm, what was the length? It's a 20 and 40, right? So look at the toggle position. So this is the extreme position when, let's say, this 20 plus 40 will become 60, and this is the maximum position, or this is the farthest position of the cutting stroke, and this is the, or there's a top dead center and bottom dead center, in short. Okay, I hope you understood till this. Now think on it, at the farthest position, that is top dead center, what is the value of the angle of the crank, and at bottom dead center, what is the angle of the crank? So that is given by theta and phi respectively. So you can clearly see during cutting stroke how much we are turning. We are turning by, from this point, right? From this point we are turning by beta, and how much time we are taking for the return stroke? We are taking alpha, right? So beta by alpha will give you the quick return ratio for this figure. Do you agree? Because I have just made a top dead center and bottom dead center. Okay, and corresponding to that, we have found the angles, and then we know, like, from the maximum angle will be for cutting, minimum angle will be for return. So you just have to calculate beta and alpha. So first of all, let's calculate theta and phi. How will you calculate theta? Sine of theta is equal to perpendicular divided by hypotenuse. So this is 10 divided by 60 or 1 by 6. So sine inverse of 1 by 6 is 9.6 degrees. Again, sine of phi is equal to 10 divided by 30. So sine inverse of 1 by 2 is 30 degrees. Okay, so you got theta and phi now. How you will calculate alpha? Alpha you can see alpha is 180 minus plus theta. So alpha is equal to 180 minus 5 plus theta. So 180 minus 30 minus 30 plus 9.6 is 159.6. And about the beta, beta is 180 plus 5 minus theta, right? 1 plus 5 minus theta. And that will end up it as 204, sorry, 2200.4 degrees. So 200.4 divided by 159.6 degrees will give you 1.25. Okay, hence, yeah, correct option is 1 point. We don't have option, we have to write here. So 1.25 is the correct answer in this case. Are you following it? Any doubt? Okay. Then I'll proceed to the next. Take one more question on this ladder cutting mechanism. And we are connecting as time is rotating uniform angular velocity of the radian per second. Okay, in counterclockwise. Okay, voice is breaking. How about, is it still breaking? Okay. Okay. Just give me a minute. Change the network connection.
You are currently the only person in this conference. You are currently the only person in this conference.
Yeah, it's showing as all full range for me, but the page is not loading. Give me a minute. Can you see my screen, or it is still? I think it's not. Mm, yeah, it's frozen. Same for me.
You are currently the only person in this conference.
Hello, hello. Not sure what's happening. Wait for 1 or 2 more minutes. If we are able to solve, then we'll continue. Um,
You are currently the only person in this conference.
can you hear me now? And see, I think it should work now. Um, yeah, yeah. Sorry for this inconvenience. Let's. Screen is loading. Okay. Yeah, it should be loaded. Yeah. So take this question and solve it now. I'll wait for 1 or 2 more minutes. A crank mechanism with a crank radius 60, connecting rod length 240 millimeter is shown in this figure. And this crank is rotating with uniform angular velocity per second in a counter action. Uh, what is the speed of the slider, they are asking. What is the speed of a slider? Okay, so something like this we can expect velocity. Something like this we can expect the uh, velocity diagram, right? So this point is C and D. This is point is, let's say, B, and And this, for example, here. Do you agree? Um, and then here we have this angle 90 degree. Yes. So with this hint, you can solve it. So you can enroll here and solve this question. Okay. So let me show here. Same thing. I have um, this total distance we have calculated uh, using right angle triangle Pythagoras theorem. Base square plus height square is equal to hypotenuse square. Okay. And velocity of BC will be velocity of point B will be BC into omega. Omega is 10 and BC is 6 millimeter, which is 0.06. So it's a 0.6 meter second is this velocity. And velocity of, so if using triangle rule, basically you can say that VC cos theta, or basically this velocity cos velocity that heavy link is again link. No, sorry, not like that. Hello. This so this is what we 0.6 divided by cos of theta is equal to divided by hypotenuse. So you should get this. Um, Looks like connection issue. Yeah, looks like some connectivity issue is there. Uh, I think we can hear and rest of the problem next class. What okay? Was almost we are at the end. Just 5 minutes. So I'll take this question also in the next class. Uh, okay, and so the last question, by the way, for from the um, this ladder gang mechanisms and balancing, etc. And the next topic which I was planning to start was flywheels and governors. So anyway, that will start in the next study in the next and so yeah, sorry for today. So we will end our session here and again continue next week. Okay, so we'll have one more session, last maybe the last session. Uh, so where we will study the problems from flywheels, governor, etc. The remaining topics, and um, will complete the syllabus. Okay. So thank you and have a good evening.
You are currently the only person in this conference.